So we learned about the natural numbers. Counting numbers are called as natural numbers denoted with n. Natural numbers including 0 are called as whole numbers represented with w. Whole numbers including negative numbers are called as integers represented with z. And integers including the numbers which can be expressed in the form of p by q are called as rational numbers. These rational numbers can be defined in the another form. Set form, these are roster form we call that we learn in 10th class. And here this form is called the set builder form. X is defined as x such that, sometimes you can take a slash also or sometimes a colon, both are correct. X is defined as x such that x is equal to p by q, where p and q belong to integers and q denominator is not equal to 0 and p and q are 4 primes. So after rational numbers, next we will get the irrational numbers. What are irrational numbers mean? The numbers which cannot be expressed in the form of p by q. Rational numbers, already we learned about the example. Suppose 4 by 4 means here 4 can be written as 4 by 1. So it is the form of p by q. 4 and 1 are integers. So it is a rational number. Next again 3 by 5. So again it is in the form of p by q. It is also a rational number. 1.2. This 1.2 can be expressed in the form of 12 by 10. Again to express counting coming in the co-primes here, so we can simplify it in the 2, 6, 2, 5, so that we will get the co-primes 6 and 5, because the factors of 6 are 1 and 6, the factors of 6 are 1, 2, 3 and 6, and factors of 5 are 1 and 5. So there is only one common factor among 6 and 5, that's why they are co-primes. So 4 is a rational number which can be expressed in the form of 4 by 1. 3 by 5 is a rational number because both are integers, p and q are integers. 1.2 can be written as 12 by 10 and it will be simplified as 2, 6 and 2 5s. Again 6 factors are 1, 2, 3, 6, 5 factors are 1 and 5. The common factor is 1, that's why the 6 and 5 are co-primes. Again these both are integers and are co-primes. So this 4 is a rational number, 3 by 5 is a rational number, 1.2 is also a rational number. These are the examples of rational number. But the numbers which cannot be expressed in the form of p by q, which is not equal to p by q, are the numbers which cannot be expressed. The numbers which cannot be expressed in the form of p by q are called irrational numbers. And the same condition follows here. P and q belongs to integers and q not equal to 0, where p and q are co-primes. So here same condition, but here it is equal to the numbers which can be expressed in the form of p by q are called as rational numbers, and irrational numbers are denoted with q dash, or sometimes yes, capital letter yes or q dash. So after rational numbers, these numbers are called as irrational numbers. The numbers which can be expressed in the form of p by q, where p and q are integers, q not equal to 0, p and q are co-primes, are rational numbers. The numbers which cannot be expressed, not equal to p by q, which cannot be expressed in the form of p by q, where p and q are integers, q not equal to 0, and where p and q are co-primes, are called as irrational numbers. For example, here 1, 2, 3, 4, 5, 0, 1 and so on. These numbers, this is a irrational number example which cannot be written in the form of p by q. And again, for example, other examples, root 2, cube root 5, 7 by root 2, and pi is a irrational number which is equal to 3.145, 6 and so on. It is a non-terminating, non-repeating decimal. That's why pi is also irrational number. These are all the examples of irrational numbers. And it is a non-terminating, non-repeating decimal. And it is a irrational number. Square root 2, cube root 5, 7 by root. These are all the examples of irrational numbers, because these cannot be written in the form of p by q. We can say, you can get out that about this here 7 by root is in the form of p by q. Okay, 7 by root 2 is in the form of p by q, but 7 is an integer, but root 2 is not an integer. That's why 7 by root 2 is not a rational number. That's why these are the examples of irrational numbers. So again I will repeat here, what are irrational numbers means? The numbers which cannot be expressed in the form of p by q, where p and q are integers, q not equal to 0, and p and q are co-primes. So these are called as irrational numbers. The numbers which can be expressed in the form of p by q are called as rational numbers. The numbers which cannot be expressed in the form of p by q are called as irrational numbers. Condition is same for for both rational and irrational numbers. So after this irrational number, suppose if we combine both rational and irrational, then we get our topic, that is what? Real numbers. So the combination of rational and irrational, together is called as real numbers. This is our main topic here. Real numbers denoted with capital R. Rational plus irrational. Or in rational, we get all the rational numbers, whole numbers, integers, and the numbers which can be expressed in the form of p by q, and the numbers which cannot be expressed in the form of p by q are irrational numbers. Both together, rational plus irrational together are called as irrational numbers. Or we can define irrational numbers as the numbers which comprises both rational and irrational numbers are called as real numbers. The combination of rational and irrational numbers are called as real numbers and are denoted with R. So this is our main topic. This is what? Real numbers. So what are real numbers means? The numbers which contains both rational and irrational numbers are called as real numbers and is denoted or represented with capital R. So first we started with natural numbers. Counting numbers are called natural numbers denoted with N. Whole natural numbers including 0 are called as whole numbers denoted with W. Whole numbers including negative numbers are called as integers denoted with Z. And the integers including the numbers which can be expressed in the form of p by q are called as rational numbers denoted with Q, capital letter Q, and the numbers which cannot be expressed in the form of p by q are called as irrational numbers. Condition both rational and irrational same condition satisfies here. And now at last the combination of both rational and irrational together numbers are called as real numbers and are denoted with capital R. Now we are going to represent the numbers on the number line. What is a number line? The numbers which represented on the line are called as number lines. The numbers which are represented on a line are called as we call as number line. So what is this first one? Natural numbers number line. So here on this line there are only natural numbers. That's why this number line is called as natural numbers number line. And here on this line there are only whole numbers, and that's why this is called as whole numbers number line. And this number line is called as integers number line, because on this line there are only integers. That's why this number line is called as integers number line. Natural numbers are on the line, so natural numbers number line. Whole numbers are on the line, so whole numbers number line. Integers are on the line, so this number line is called as integers number line. Pause. Okay children, now we learned about the natural numbers number line, whole numbers number line, integers number line. So then how to represent rational numbers, on the number line. And also sometimes we will also on this same integers number line we can also represent rational numbers, irrational numbers. Both rational and irrational can represent on the same integers number line, and at last we call it as a real number line. Let us see how we represent the first rational numbers on a number line. So now we are going to learn about the representation of rational numbers on the number line. Rational numbers in the sense the numbers which can be expressed in the form of p by q, where p and q are integers and q not equal to 0 for the p and q are co-primes. So here how to represent the rational numbers on the number line. So in rational number there are different types of numbers which are in the form of p by q. Here if you see here, sometimes we call when the numerator is less than the denominator. When the numerator is less than the denominator, we call it as a proper fraction. So here also the numerator is less than the denominator, numerator is less than the denominator, numerator is less than the denominator. But here we have the positive numbers, here we have the negative numbers. These are positive rational numbers, these are the negative rational numbers. So one thing you have to keep in mind, whenever this proper fraction, when the numerator is less than the denominator, denominator, always it lies, the numbers lies between 0 and 1, where positive rational numbers which are proper fractions lies between 0 and 1, whereas the proper fractions which are negative symbols, that is negative rational numbers where the numerator is less than the denominator, that lies between -1 and 0. Let us see how we can represent. So this is a very important point you have to keep in mind. Once again I will repeat here, 1/2, 3/4, 3/5 are the proper fractions because the numerator is less than the denominator. Here also numerator is less than the denominator. Here all these are all positive numbers, these are all negative numbers. These positive numbers where the numerator is less than the denominator lies between 0 and 1. Any number, any proper fractions which are positive, any proper fractions which are positive where the numerator is less than the denominator always lies between 0 and 1. You have to keep in mind this one. Whereas here also 1 by 2, 3 by 4, 3 by 5 given less than the denominator, but these are negative rational numbers, and these numbers where the numerator is less than the denominator and these are negative numbers lies between -1 and 0. Any numbers you take which are proper fractions and which are negative lies between -1 and 0, and here these are the proper fractions which are positive numbers where the numerator is less than the denominator lies between 0 and 1. This is very important to avoid confusion here. Let us see how to represent these numbers. I have taken here 3 examples which are positive rational numbers and here which are negative rational numbers. Here the numerator is less than the denominator. Here also the numbers are less than the denominator. These numbers lies between 0 and 1. These numbers lies between -1 and 0. Let us verify and understand how to represent these fractions, that is proper fractions, positive, proper fractions, negative, where the numerator is less than the denominator, which lies between positive lies between 0 and 1, negative proper fraction which lies between -1 and 0. Let us take the first example. Let us take the same integers number line here. This is the number line, 2 arrow heads on both sides. So here, as I said here, these are the proper fractions which lies between 0 and 1 here. So now let us take here this side as 0 and this ending as 1. There are two different ways. Let us learn the first method here. Left side it is 0, as you see in the number line, left side is 0, right side is 1 always. So left side is 0, right side is 1. So the number first I am taking the first problem, that is 1 by 2. How to represent the 1 by 2 on the number line, which is a rational number, 0 and 1. First of all we have to check the denominator. Denominator is what here? 2. Means here between 0 and 1 we have to divide into 2 parts, equally into 2 parts. So here suppose if we take in the middle, by using scale you can divide equally here. Suppose this is the middle one, so this is 0 and this is 1 and this is 2, because 2 no, 1 part and 2 parts. So suppose this can be written as, first I write 0 because the denominator is 0 by 2. 0 next number is 1, so 1 by the denominator is 2, and again 1 afterwards 2 and the denominator is 2. 2 gets cancelled, you get 1, and 0 by 2 is nothing but 0. So here 0 by 2, 0 of course next number is 1, and again 1 by the denominator is 2, and 1 after 2 by the denominator is 2. 2 by 2 gets cancelled, again you get 1. So 1 by 2 means this is the 1 by 2 where we can represent number line, 1 by 2 on the number line. So here this is 1 by 2. So now suppose if we take here 3 by 4, suppose if we take here 3 by 4, suppose again here this is 0 and this is here, this is here. So we have got to represent 3 by 4 here. This is the second problem, 3 by 4. Again I will write here 1 and the denominator is here 4. Now we have to, between 0 and 1 we have to divide into 4 equal parts. Say 1, approximately I am doing with scale, we can do as perfectly can do here. 4 parts. 4 parts means as we get here 3 lines, 1, 2, 3. So up to here 1 part, 2 parts, 3 parts and 4 parts. Suppose here 0 by denominator is 4. 0 next number 1 and the denominator is 4, and 1 of next number 2 again denominator is 4. 2 next number 3 and the denominator is 4. 3 next number 4 and the denominator is 4. 4 gets cancelled, 1. We need 3 by 4, and this is what 3 by 4 on the number line, and 3 by 5 here. Suppose now 3 by 5 here. Now third one we are taking here 3 by 5. So here again 0 here and again here it is 1 and again denominator is 5. We have to divide between 0 and 1 into 5 parts. 1, 2, 3, 4, 5. Still you can do exactly into 5 equal parts. Equal parts are very important. So 0 can be written as 0 by 5. 0 next number 1. 1 by 5. 1 next number 2. Denominator is 5. 2 next number 3. And the denominator is 5. 3 next number 4. Denominator is 5. 4 next number 5. Denominator is 5. So 5 gets cancelled 1. 0 by 5 is nothing but 0. 3 by 5. 3 by 5 will get here. This is the 3 by 5 to represent how we are representing on the number line. So these are the positive fractions which we are represented on the number line. In the same way, we can represent the negative rational numbers that lies between 1 minus 1 and 0. Minus 1 and here we will write minus 1 because minus 1 on the left side, right side on the 0. The same way we can do it. We can same way we can